Aloha, welcome everyone. We'll be starting shortly on this panel for designing for zero energy multifamily buildings. All right, well, welcome. As we start to get settled in, if you haven't been part of session one, we'd love to know where you're tuning in from for the first time. So please feel free to share that into the chat box here. And as we're waiting, allow me to introduce myself. My name is Brian K. Aloha. I am the Executive Director of Hawaii Energy, a longtime supporter of AIA Honolulu, and excited to be here and be your moderator for today. All right, we've got a few people from here, and probably a lot of folks on island. So again, welcome. We're gonna get ready and start to dive in to our session today, because this is a really exciting panel, something that's near and dear to my heart. But before we get into that, as a reminder, here are just some quick instructions to make sure that you get the best out of our virtual session for today. You'll see at the bottom of your screen a Q&A box where you can ask any questions that you may have for our panelists. And our staff will make sure that we get those questions in time for the Q&A session itself. If you're experiencing any technical issues, please contact our tech support team at 808-454-7804. Also, this session qualifies for AIA CES learning units for AIA Honolulu, is the registered provider. So all those attending today, AIA members, will have the credits applied to their ANA online transcripts within 10 business days. If you're not an AIA Honolulu member and need proof of participation, you can contact AIA Honolulu for a session certificate. Okay, with that out of the way, just a quick look at our schedule. Hopefully you've been tuning in since this morning, but here we are at 12:30 for our panel on designing zero energy multifamily buildings informed by simulation and policy. Building operation accounts for 39% of global greenhouse gas emissions, and Hawaii is experiencing a significant demand for housing while also working towards a 100% clean energy commitment by 2045. We have a great array of speakers here today. Presenting first will be Wendy Meguro and Elliot Glassman. They will be setting the stage by sharing their research and demonstrating a replicable process to reduce energy use and estimate future thermal comfort in multifamily residential buildings. Following Wendy will be John Delaney, who will be building off of what Wendy and Elliot present and share a little bit more about the Arroyo, which is an affordable housing multifamily project by Koning Eisenberg Architecture in Santa Monica, California. This project exemplifies many high-performance building strategies relevant for Hawaii and received LEED Platinum certification and an AIA Housing Award. Very cool. So first, let me introduce Wendy. Wendy is an architect and associate professor at the University of Hawaii, whose teaching and research focuses on high-performance architecture grounded in building science and professional practice experience. With a joint appointment in architecture and Sea Grant, she also studies enabling coastal communities to adapt to sea level rise. Wendy earned degrees in architecture and building technology from the University of Hawaii and the Massachusetts Institute of Technology. Students learned from her experience working at Atelier 10, where she led the environmental design for laboratory, educational, office, library, museum, and multifamily buildings on teams that were led by Renzo Piano Building Workshop, Grimshaw Architects, Kieran Timberlake, Enid, and others. But what's really cool is the UH Board of Regents awarded Wendy one of 6 2021 Regents Medals for Excellence in Teaching, which is the highest UH system-wide teaching honor. So congratulations and welcome, Wendy. Second, I would like to introduce Elliot Glassman. Elliot is a senior associate and senior technical principal with Built Ecology, which is WSP's high performance and sustainability group. He is also the national leader of computational design for building systems and the leader of WSP's Global Computational Design Group for WSP Next. Elliott obtained his Bachelor of Architecture from the New Jersey Institute of Technology and a Master of Design Studies in Sustainable Design from the Harvard Graduate School of Design. In 14 years of combined professional practice as an architect and a sustainability consultant, Elliott has worked on various projects around the world, each requiring a unique resource and response to a diverse set of climate, site, and programmatic conditions. His main area of expertise is passive building design for energy, daylight, and comfort. Other areas of expertise include water efficiency and renewable energy. Welcome, Elliott. Our third speaker today is John Delaney. John is a project architect and sustainability coordinator at Koning Eisenberg Architecture, with a research focus on policy, construction methods, technologies, and materials. He has contributed to numerous award-winning institutional and multifamily residential buildings in the US and abroad, and brings expertise in building systems and BIM integration. So you can see we have a great panel here this afternoon. Let's jump into it. First, let's welcome Wendy and Elliott to the stage. The floor is yours.
Thank you for that lovely introduction, Brian. One moment while I share my screen. All right, it should be sharing, so please let me know if you can't see it for any reason. So hello, everyone. Thank you for joining us today. Welcome to Designing Zero Energy Multifamily Buildings Informed by Simulation and Policy. Our goal today is to share an analysis process that the audience may replicate, also to point out tools and information that may be applied in building designs and policy now, and illustrate these ideas in an award-winning building. Building operation accounts for a significant portion of global greenhouse gas emissions, about 28%. We see an opportunity to broadly improve building energy performance, particularly in the new, dense, mixed-use neighborhoods developing around the rail stations in Honolulu, Hawaii. A business-as-usual approach of simply meeting building energy codes will not achieve Hawaii's 100% clean energy goals. We will discuss how cities across the US use policy to accelerate building decarbonization, which we heard a little bit about this morning, and implement their climate action plans. We will share how design professionals and building owners may set relevant, ambitious, quantitative building energy targets as early as the pre-design phase. We will explain our replicable process using early design phase energy modeling to inform design decisions. And recognizing that some building projects do not use design phase energy modeling, this research identifies the strategies that most effectively reduce energy use and emissions. We will also demonstrate the potential for net zero site energy and peak load reduction. And finally, we'll take a look ahead and examine how future hotter weather might negatively impact thermal comfort. Most of the presentation that Elliott and I will share is based on our article, long title, Evaluating Energy Targets and Efficiency Measures in Multifamily Subtropical Buildings Through Automated Simulation. It was published in Technology, Architecture, and Design in 2021, and it is free to access online. It is based on work by a larger team at the UH Environmental Research and Design Lab and WSP. The team simulated a conceptual design for two multifamily residential buildings shown here. The conceptual building massing was in the earliest stages of consideration for development by the State of Hawaii Office of Planning and the UHCDC. We simulated two 5-story buildings, each with an exterior walkway and 40 one-bedroom dwelling units per building. Although we analyzed this specific building, the energy targets and efficiency measures that we share today are intended to apply widely to future residential buildings in Honolulu, and the process may be replicated for different building types. The simulation engine Energy Plus 8.9 was used through the Rhino 6 software's Grasshopper plugins called Honeybee and Ironbug. First, we'll share a process and resources to set building energy use intensity targets. In order to set building energy goals prior to commencing energy modeling, the team compared the energy use intensities for peer buildings using data on existing and simulated buildings from CBEX, Energy Star, Hawaii Energy, and the New Buildings Institute. In this graph, each bar represents a building with a relatively similar climate and program, and you can see the large range of EUIs. Design teams in the audience can follow a similar process to set EUI targets using the resources shown on this and the following slide, including Hawaii Energy's benchmarking website, the Zero tool, New Building Institute's Zero Energy Commercial Building Targets, CBEX, Energy Star Target Finder, which references CBEX, and in addition, during design, teams may track their predicted EUI using the AIA Design Data Exchange. Now, I'll give a preview of the energy modeling results as compared to these benchmark buildings. We simulated an energy model called IECC 2015 baseline that minimally complies with the Hawaii State Energy Code prescriptive requirements. The team observed that the simulated IECC 2015 baseline building EUI was only 8% lower than the average EUI of existing multifamily developments in Hawaii. This indicates that driving building energy consumption down dramatically will require much more than just code minimum design. We also modeled other combinations of energy efficiency measures and were able to reduce the EUI to 14.9 and 10.9 kBTU per square foot per year, which is far below the peer buildings.
Next, we'll share a replicable process using early phase design energy modeling and automated parametric studies that we use to identify the most effective energy efficiency measures. This table shows the energy modeling inputs used for the parametric study. For each aspect of the building design, such as envelope, plug loads, air conditioning, ventilation, domestic hot water, and lighting, we first identified parameters that would be compliant with the IECC 2015 prescriptive requirements, and then selected 2 degrees of improved performance options for each category to study. Now, a standard approach to this type of energy analysis may include modeling variables independently or modeling a number of predetermined combinations of design inputs, then comparing these scenarios to the baseline. But that approach risks missing interactions between different energy conserving measures where the impact may be more or less than the sum of the parts. So we use automation to run all the possible combinations of the design variables and then created a large data set representing the whole range of possible performance outcomes. The entire design space was visualized on this chart called a parallel coordinates plot. Each scenario that we modeled was represented with a single line connecting the input variables that define the case with the corresponding outputs on the columns on the right. The lines are each color-coded based on the most energy efficient options with the performance of the IECC baseline provided as a reference. From this plot, it was apparent that the high efficiency HVAC and passive cooling cases provided the overall best energy performance. The data set plotted on the parallel coordinates plot could be dynamically sifted by constraining desired outcomes or design variables, input variables to identify the remaining pathways to high performance outcomes. Another way of that we viewed the data was a sensitivity analysis of each individual variable on EUI. The length of each bar represents the range of possible outcomes given the single fixed variable. The color coding represents the percentage improvement from the worst performing option within each grouping. The greener the color and the smaller the range, the more impactful that individual variable is towards improvement of EUI. Now, this analysis illustrated that HVAC type, plug loads, domestic hot water system selection, and ventilation rates had the greatest impact on overall energy use.
So to visualize that, here we summarize the active strategies that design teams may utilize for greatest annual energy savings. We saw that the most impactful strategy by far is to use either passive cooling or a high efficiency split air conditioning system with heat recovery ventilation and programmable thermostats. Also, provide fresh air at the minimum ventilation rate. Next, reduce plug loads with Energy Star appliances and smart controls. For domestic hot water, use high efficiency heat pumps with or without heat recovery from the air conditioning system or solar thermal.
And we applied the same sensitivity analysis, not just on EUI, but also on peak cooling loads, which revealed that the most impactful variables in this case were reducing window to wall ratio and enhancing solar protection through improved glazing and exterior shading. The facade properties that lowered solar loads and the HVAC selection were both important for reducing the building's peak electrical demand.
Passive strategy takeaways included specifying a stringent solar heat gain coefficient for the glazing, using the code prescribed window to wall ratio of 30%, incorporating exterior shading with a 0.5 projection factor. Also, where the site allows, design teams should orient the building to have long north and south facades, which receive less solar radiation than the east and west facades. When testing the impact of orientation on the baseline building model, we found that those long north and south facades resulted in a 4% energy savings and a 19% peak cooling savings as compared to the same building rotated 90 degrees. So now that we know the most effective energy efficiency measures, how much energy savings is possible when we combine them?
Based on the observations from the parametric analysis and the complete data set, the team generated selected combinations of variables that were most impactful when modeled together, and then compared them to the IECC baseline case. The table shows these combinations and the parameters selected for each. The first combination, entitled Developer Preferred, included energy efficient measures that the team deemed likely to be employed if the state were to develop the building today. Inputs were based on recommendations from the NBI Multifamily Guide and the team's professional experience. The two highest performance combinations demonstrated the best performance achievable with current technology. The aggressive yet feasible EUIs in the highest performance cases could inform state targets or code alternative compliance paths.
The highest performance combinations 1 and 2 include lower window to wall ratios, external shading, a stringent solar heat gain coefficient, high performance cooling and ventilation, lower lighting power density, limited plug loads, a moderate facade infiltration rate, and a high efficiency heat pump water heater. The highest performance combination 1 has mechanical cooling and ventilation, whereas combination 2 uses passive cooling and natural ventilation. Here are the results. The combinations of energy efficiency measures show potential for moderate or significant savings of energy, energy cost, and emissions. The developer preferred case's estimated EUI is 27 kBTU per square foot per year, which is a 19% improvement over the IECC 2015 baseline. But the highest performing case's estimated EUI is 14.9 with full mechanical cooling, or 10.9 without mechanical cooling. This is a 56 and 68% reduction, respectively, compared to the baseline case. And as we mentioned earlier, this is far below the benchmark buildings. So can this 5-story multifamily building be net zero site energy? This image illustrates the roof area required to generate 100% of the annual site energy for each of the combinations of energy efficiency measures. Rooftop PV can offset the highest performance combination's site energy use, but not the IECC baseline or developer preferred combinations. Electricity generated by rooftop PV is not sufficient to offset the annual source energy use for any of the simulated combinations. What is the size of a battery system that could shave at least 10% of the building's estimated peak electricity demand? 10% is the threshold for the LEED version 4 Energy and Atmosphere Credit 4 regarding demand response. This graph shows hourly electrical demand on the autumn equinox for the IECC 2015 baseline and the effect of a 50 kilowatt hour battery system. When the battery discharges electricity during the high load hours in blue, it reduces the peak demand by about 10 kilowatts or more than 10%. We know Honolulu will be hotter in the future, but how much hotter? And what does that mean for people's thermal comfort in Honolulu's many multifamily buildings without mechanical cooling? We simulated an unconditioned version of the baseline multifamily building using 8 different future weather files. The weather files are based on the 2014 Intergovernmental Panel on Climate Change, IPCC report, using 2 greenhouse gas emissions scenarios. One in which greenhouse gas emissions peak at 2040 and then decline, and another scenario in which greenhouse gas emissions rise through the year 2100. Using the ASHRAE 55 adaptive comfort standard, the baseline multifamily building is currently estimated to be comfortable about 88% of the time without fans and 96% of the time with fans. The simulation estimates it is comfortable significantly less often in the future, as low as 75% of the time in 2050 and 58% of the time in 2080. Encouragingly, fans, shown in the graphs at the right, are a great low energy strategy to increase the number of comfortable hours. So what can the audience do now? Reduce building heat gain with exterior shading, specify glazing with a stringent solar heat gain coefficient, limit the glazed area, provide adequate facade open area for natural ventilation, and provide ceiling fans. Moving on from the unconditioned building, what happens in a mixed mode building? Using the future climate scenarios, we studied the increased future energy use in a version of the baseline multifamily building with mixed mode ventilation. Hotter future climate scenarios mean the opportunity for natural ventilation will decrease over time, increasing the building's energy use intensity from approximately 29 kBTU per square foot per year today to approximately 34 to 42 in the year 2080. This increased energy use impacts demand on the electrical grid or on-site renewable energy sizing. Design teams in the audience can find thorough guidance on building performance simulation and designing for energy in the AIA's online resources shown here. In addition, the climate consultant tool can quickly generate climate analysis graphics. In summary, designers and policymakers may use this new quantified information to significantly reduce energy use, greenhouse gas emissions, and peak electrical load in multifamily buildings in subtropical climates. Architects and utility providers may use the estimates of poorer thermal comfort and increased energy use with the future climate scenarios to inform their building designs and craft financial incentives. The team discussed the application of this study with leaders from the State of Hawaii Office of Planning, the State of Hawaii Energy Office, and Hawaii Energy. Some of the suggested next steps included crafting financial incentives for energy modeling, conducting similar studies for other building types, conducting a Hawaii-based life cycle cost analysis, and incorporating energy targets and efficiency strategies into new building project objectives and energy codes. We would like to extend our deep gratitude to our sponsors and collaborators shown here, in particular, the Hawaii Natural Energy Institute.
Next, we'll turn it over to John to dive into the Arroyo, an outstanding built example of energy efficient multifamily housing to learn how the project team actually incorporated many of the energy efficiency measures that we've been discussing today, while earning LEED Platinum certification and an AIA Housing Award. The Arroyo building is also of interest because the building's type and scale is reminiscent of our study building, and it's also located in Los Angeles, California, where the climate is similar to Honolulu, albeit with slightly cooler temperatures and lower humidity.
Okay, thank you, Elliot. I'm just going to go ahead and share my screen. Okay. If everyone can see the image, this is the Arroyo. This is a 64-unit, 100% affordable housing project in downtown Santa Monica. It was designed in 2014, 2015, but the development story for this project actually goes back several years before that, as it is a sister project to a market rate project called 500 Broadway, which is also located in Santa Monica. And that sort of relationship had quite a significant impact on the financing for this project and the design. So I'll get into that as we go along. So this is just an image of the context, kind of turning around and looking towards the ocean. It's about 7 blocks from the ocean. You can see where the Santa Monica Pier is located in relationship to the site. It's also close to Santa Monica High School, Tongva Park, 3rd Street Promenade, which is a major retail district. It's also located close to several libraries, and you can see 500 Broadway, which is the sister project, is located closely. So given the proximity of parks, markets, schools, and other infrastructure, including the Los Angeles Metro Rail, this is actually a very prime location, in addition to just being a 10-minute walk to the beach. So there's lots of local amenities to take advantage of for this project. Sort of an image of the sort of local context at the block scale. There's lots of construction going on. The Arroyo was essentially a pilot project for this area. 10 years ago, you probably would have seen lots of single-story commercial development and Lincoln Boulevard as primarily a vehicular thoroughfare. But you can kind of see on the left and to the bottom of the screen how much construction is going on there now. But the Arroyo was essentially the first high-density multifamily project that was located in this area. So essentially, we believe that affordable housing can act as a catalyst for these sorts of developments that are dense and pedestrian friendly. Previously, this area was not very pedestrian friendly. So who lives at the Arroyo? There's 64 families, so it's a 64-unit project. 63 cars, which is actually less than would normally be required for a market rate project. It's actually below zoning requirements. The reason that we provide parking, even if it's not required by code, is because a lot of low-income housing residents do depend on the car for their livelihood. So we always, when we're thinking about the tenant, we want to make sure that we're providing the amenities for the tenant that they need, so they can maintain their livelihood. 50% of the units in this building are 2- and 3-bedroom units. This was identified by the City of Santa Monica and by CCSM, which is the Community Corp of Santa Monica. This was the developer. This was identified as the target demographic for this building. So there's 116 bedrooms total for this project, and that sort of translates to 126 bicycle parking stalls and also 44 trees on site to act as sort of a landscape amenity. I want to talk a bit about the financing and funding for this project. So this is an image below of 500 Broadway. This is the sister project. Essentially, it's very similar to a public-private partnership in that a private developer doing market rate housing purchased land to do their development and also purchase land to do the affordable development instead of having to do mandated affordable on site. So they were able to purchase another site and then deed the land to CCSM, which is Community Corp of Santa Monica, at an extremely discounted rate. So that provided a big financing benefit to the nonprofit developer. And that also allowed us to add additional density. So 26% of the units instead of 28% if required on site. So I'll just talk a little bit about the framework of how affordable housing gets developed in Santa Monica and in the Los Angeles area. The team ethos is pretty self-explanatory. This just means getting a team of like-minded architects, consultants, and developers together who have similar goals of providing a social benefit as well as doing sustainable buildings. In addition, projects are funded by tax credits, grants, and other incentives. Tax credits are administered by CTCAC, which is essentially the California Tax Credit Allocation Committee. It's a state agency that administers NOFA, which is issued by local development agencies to address the needs of their communities. And the NOFA requirements often are above state code and tailored to affordable housing. And successful projects generally earn more funding points for meeting better sustainability targets. So the developers essentially are able to sell the tax credits to private entities to raise capital for these projects. So essentially the NOFA dictates to a large degree what sustainability measures we're using in these projects. Grants are another way to get funding. HCID, which is the California Housing Development in California, maintains a number of active grant programs, including affordable housing and sustainable communities, HSC, and infrastructure grant, some of which have unique requirements and some of which require compliance monitoring. So these are just ways to additionally increase the level of architecture that you're getting for affordable housing. These can include things like street trees, other landscape amenities, native plantings, and similar sort of things. Planning and design review. So the city of Santa Monica has a fairly intensive planning and design review process that entails a number of community meetings. And it locks in sustainability goals that are unique for the local community very early in the design. So the city has a vested interest in the project, and community members also have a vested interest in the project as well. And so large housing developments in Santa Monica are almost always discretionary and rarely by right. And the Office of Sustainability and the Environment, which is another, is essentially its own section of Santa Monica city government, issues REACH codes with additional requirements for EVs, energy efficiency, et cetera. The utilities, Santa Monica also provides municipal gray water. So we're able to use municipal gray water for irrigation. In addition, we can purchase 100% renewable electricity through the Clean Power Alliance, which is sold to the local utility, which is SCE, and then delivered to the project. Also, the city also provides rebates for homeowners who go above and beyond just general sustainability sort of baseline. So in that sense, the city and utility companies are able to additionally increase the baseline for sustainability. Let's talk a little bit about the design of the arroyo. So where does the name come from? An arroyo is a Spanish name for the geographical feature of a dry stream bed that channels stormwater during the Southern California rainy season, which is only 2 to 3 months long, and it's usually in winter. That's important for this project because the initial site was, if you can kind of see, this is essentially a car wash and auto maintenance center, but right down the middle, there is a stormwater easement for a large stormwater drain that's located below grade. It has really very little to do with how the building needs to function. It's really all to do with the stormwater easement, and you can kind of see how big that pipe is down below. So when you're looking at the site plan, you can kind of see how it bisects the site. There's the stormwater easement. So you have essentially two bars of units on the north that so essentially it's the same sort of orientation that Wendy was mentioning that is ideal for energy efficiency. You have sort of long bars in an east-west orientation where you have primary views to the mountains and the beach on the north and south towards the courtyard. And you can kind of see just based on a site diagram how the building is working. The well-landscaped courtyard over the stormwater easement, which is ideal for sunlight and predominant breezes from the southwest. A double loaded bar on the north edge of the site and a single loaded bar on the south edge with views to the courtyard. A parking entry off the alley to allow for pedestrian friendly frontage and essentially maximize outdoor space. So areas like the back patio, vegetable garden, covered gathering and activity space, the entry, all of these which would in a typical building be indoors are located outdoors to minimize the amount of conditioned space and take advantage of the climate. So just some images of the building. This is sort of our approach to street frontage. And so we're essentially making spaces with a high amount of detail that cause the eye to slow down in these spaces and that are beneficial to public life of the street and lives of the residents. It's almost like a little oasis because Lincoln Boulevard is a heavily trafficked street. So we really want to make sure that when we're doing affordable housing in an urban infill situation, that the project feels domestic and that the residents can feel at home. And landscaping has a big role in that. And so we're, in this sense, we try to maximize the amount of planting we're able to get in native soil. Here's just an image of the outside of the building, which this is the north facade with sunshades that are optimized to block harsh light from the west, but permit light from the north, and to allow for ideal views to the ocean and to the mountains, to Santa Monica Mountains. Some additional images, you can kind of see the freeway sign. So this project is in close proximity to the freeway. So we had to take measures to provide additional air filtration, so MERV 13 filters, even though they were not required by code at that time. That was an additional step that we took to ensure good air quality. You can kind of see that we did provide some large sliding doors and Juliet balconies just to provide additional sunlight to the interior of the units where it was appropriate, and to provide cross ventilation. The rear of the project shows some of these public spaces and also kind of a feature stair that also acts as an additional social space in the vertical plane. Additional images of that facade, which starts to show some of the equipment on the rooftop, which I'll get into. There's the stair again. We found during post-occupancy just walkthroughs that this stair was actually being used a lot as a social space where kids could run up and down and play. So that was kind of a surprise. Kind of a view of the courtyard. And then kind of moving through the courtyard so you can see how the landscape is sort of grown in and it becomes sort of a place for respite from the street. Additional views. So just kind of a summary of sustainability strategies. Primarily we wanted to make sure we were reducing the amount of conditioned space. So open corridors, large operable windows and sliding doors to capture ocean breezes from the southwest. In addition to having good quality natural light and good views to the north and west. On the roof, PV and solar hot water panels, high efficiency AC units, high albedo roof, so cool roof. For units, operable windows, open air corridors and sunshades, and courtyard, large trees for shade, open-ended courtyard, drought tolerant plantings that you can kind of see where the storm drain is located. I'll just point out some of the roof infrastructure. You can kind of see all the different pieces of infrastructure that are competing for space on the roof. There's mechanical units, there's the solar thermal system, there's common area mechanical unit, PVs, facade access, so anchors, maintenance areas, kitchen exhausts, plumbing vents. So it's on an urban infill project, it can be very difficult to reach net zero, even if you, in theory, if you did cover 100% of the roof, you may be able to get there, but a lot of times it's not practical. So this just shows where the mechanical, the mini splits are located for the individual units. This shows the amount of space that's taken up by the solar thermal system. So this was done on a previous code cycle, so 2016 code, where you got more of a benefit in your state energy modeling through the state energy modeling software for solar thermal with gas preheat versus heat pump water heaters, which hadn't been really integrated into the software yet. So it was really more of a benefit for our compliance to provide the solar thermal system, even though the efficiency is not as great as doing all PVs with heat pump water heaters. And it's also quite expensive to provide this infrastructure. So it just kind of shows how things have changed in a short amount of time. And then just a kind of a simple diagram of the unit mechanical layout, sort of noting some things we may have done differently, which was add ceiling fans. For a one-bedroom unit like this, it's also cost effective to do individual fan coils instead of the ducted system. It tends to be a cost benefit. Provide MERV 13 filters instead of MERV 8. So that's becoming fairly standard now, especially as we're dealing more with fires. In California, you can currently do balanced or unbalanced ventilation. In a balanced system, you have ducted fresh air that's filtered and is kind of on demand, whereas unbalanced, the exhaust fan's running continuously and fresh air comes in through leakage. Again, we're sort of preferring that fresh air is ducted now that sort of the fires have become a more acute issue and air quality is a more acute issue. So we'd actually prefer to continue doing this method. Additional views of what's on the roof, so you can kind of see all the different things that are taking up space. The gas boiler, so you can kind of see the complexity of the infrastructure that's required for a gas boiler. So if we were doing this project today, we may replace with an individual heat pump water heaters like a Sandin or a centralized system like Colmac. And then the size of the solar thermal storage tank is also quite large. So that you have to account for that as well. This is an interesting image because it kind of explains how zoning restrictions have they make it so floor to floor height's very tight. So the market has sort of dictated that you get these super slim mechanical units. So this just kind of shows how much space they take up in the soffit. We call them pancake units. And then just an image of the interior of the unit. So sort of getting an idea of what the light quality is and what the views are towards the mountains. And then sort of a summary of the performance metrics. Performance beyond Title 24, which is the state code, 19.8% better than Title 24. And also additional open space added beyond code required 16.2. This is something we try to achieve in most of our projects because open space tends to be a very desirable amenity. A summary of the lead project checklist. So this was sort of our final point total. And I think our performance was decent in energy, but we did do quite well in sustainable sites. And that just goes to the urban infill nature of this project and location that's close to transportation and schools and other community amenities. So big picture, I think in addition to talking about housing in terms of decarbonization and energy efficiency, we have to talk about it as a unit of social equity. So it really contributes to the resilience of cities and to the resilience of neighborhoods. It's also a fundamental economic building block. So when we're talking about getting units to market, we have to consider, why does it take so long and why is it so expensive? So we're really trying to bring it to market faster, bring it to market less expensive. And so these priorities sometimes can be seen as competing priorities, sustainability, but it doesn't necessarily have to be that way. We kind of have to think of them all at the same time, because a resilient city is a more sustainable city. And a key characteristic of a resilient city is a city where it doesn't have as acute of a housing crisis. Also focus on industry, which is inputs, versus market, which is outputs. So LEED and other sort of scoring system was focused more on the market. So sort of marketing the work that we're doing, but in the future we'll focus more on industry and what goes into the building. So that goes to thinking about what's the present and the future, and also doing more post-occupancy evaluations. So really thinking about going back to these projects years later and seeing how we're doing. So I'll just summarize 2 years later. You can kind of see how it's really growing in. It was really surrounded by trees, which is a very different experience than you get from the street. And so see children enjoying the project. Additional views of the landscaping. You can see from overhead how the landscaping is really growing in. Kids playing on the stairs, which we found, was a big surprise. And basketball. And then just showing an example of using the public area, using outdoor space as a public area, as opposed to enclosing it and conditioning it, taking advantage of the climate. And just showing some post-occupancy energy data. So we're able to get yearly readouts from our PV array, which shows CO2 emissions saved and equivalent trees planted. Also, it shows comparative energy by month per year. So this year, during the summer months, we're actually quite below the estimated target. It was consistent in 2019, 2020, but this year we're lower. Hard to say what the reason for that is, but one possible reason is that the solar panels haven't been cleaned, and it's really important to clean them in Los Angeles because they can get quite dirty just from ambient air. I was actually on a project this morning checking out the thermal array, and it was actually very dirty. So it's actually important to meet with your owners and talk about maintenance. Domestic water use, the project uses about per month on average around 300,000 gallons of water for 64 residential units. Interestingly enough, in looking at utility bills, we found that 60% of the total was just for the common laundry room, because we used EPA WaterSense, very low flow water fixtures for all the other fixtures in the units. So it ends up being that laundry room uses a majority of the water. And that's important when you're deciding to do things like gray water systems. You really don't get much cost value for doing gray water systems for units, not only because of it's not using as much water, but also because it requires additional health department permits. So it's a much more complicated system. Santa Monica actually allows you to do gray water for laundry rooms without additional permits. So this is, just goes to reiterate or sort of support that strategy. Additionally, so this is a greenhouse gas emissions report, just showing the relationship between gas, which is essentially just the laundry room, because the mini splits are electric, and water heating is counted as a separate metric. So the gas for the laundry room and other miscellaneous appliances is actually quite high relative to the other sources of greenhouse gas emissions. So this is just reiterates how important it is to go to all electric. And so that's it for the Arroyo. I'll kind of talk about, just for a second, some policy, getting involved in shaping policy. There are ways to take action and get involved. One is primarily through local government, planning commission, technical advisory roles on writing policy like Zero Code. You can also write letters and give testimony. There are numerous professional organizations like the IAA Committee on the Environment or COAT, US Green Building Council, ILFI, and others, where you can really, in addition to doing outstanding work, you can also sort of help raise the floor on a lot of these sustainability issues by really helping to shape policy. So I think it's really important as architects to get involved in these processes and understand how they work. So some examples of some of the tax credit and grant programs, some links to these programs just to see what they entail. Incentives, rebates, Zero Code, codes for climate, additional resources to kind of get involved and help shape some of these things. This is just a chart that is just an example of stretch codes that have been instituted in various cities. Santa Monica would be one of those. It's a locally mandated code or alternative compliance path that is more aggressive than base code. So resulting in buildings that achieve higher energy savings. So that would be the definition of a REACH code. So there are numerous cities that have started to pass these. And so that would be it. I'm going to hand it.
Awesome. Thank you, John. Great presentation on the Arroyo. Very, very exciting project. And obviously, Wendy and Elliot, really informative study that you put together too, as well as just looking at how do we design and build towards it. So a lot to unpack here, not a lot of time, but maybe I could start with a lot of the conversation towards, at least at the end, John, you were mentioning a little bit how we need to drive codes, what else might need to be done to kind of push and raise the bar on codes. But really for John and the entire panel, what do you see as the impact of increasing the stringent energy codes and requirements on the design process?
I think for affordable housing, the codes set a baseline, but generally we're required through the various funding sources to go above and beyond those code requirements. So essentially by doing this work, we're already prepared for any sort of code revisions that come through, especially when it comes to doing housing work. So in that sense, we're almost ahead of the game. And our clients are ahead of the game too. They understand what they need to do, and they understand what kind of foresight they need to have to anticipate these things. And what's also interesting is that the funding sources generally revise their requirements on a yearly basis, whereas the code adoption is on a 3-year cycle. So we're generally having to be a lot more flexible with this stuff than we would be if we were just trying to anticipate the next code revision. So in that sense, it's been really good. So we're essentially doing research and executing projects at the same time because we're trying to keep track of all this stuff.
Wendy, Elliot, anything to add?
Sure, I can add my 2 cents on codes or more stringent energy codes. There are a couple of resources that I think might be useful to the audience on that subject, and John showed them. So one of them is the Zero Code, and I know we talked about it in Honolulu before, and it provides a code adaptable language for zero carbon new buildings, and you can tailor it by state. We also might want to consider the Building Decarbonization Code, and that's an overlay to the new 2021 IECC. And we also might want to ask for assistance from a program from New Buildings Institute and Rocky Mountain Institute called Codes for Climate. and they give technical assistance to get climate aligned codes. So I think there are opportunities out there to be able to push. And then the other thing that I think is relevant to talk about, especially with the architects in the audience, is the subject of education on new and more stringent energy requirements. So I think the State Energy Office does a really great job putting out trainings for new energy codes. And in the presentation earlier today, we talked about energy and water building benchmarking. And I remember in New York City, when the local law for benchmarking rolled out, there were a lot of trainings on that topic for multiple years. So I think something like that might help support the community here in getting used to the benchmarking requirements. And then finally, that training doesn't have to necessarily be quite as formal as those two venues I just described. So professional organizations like the AIA, they might be able to host formal or informal trainings and discussions on more stringent energy codes. Thanks.
And just to add on, I would say, codes are a great mechanism for raising the floor. I'm based in New York, and the projects that I work on are across the U.S. and other countries, and sometimes it's very easy to do the code minimum, whereas we really, in order to address, some of the climate change that's happening and some of the challenges with energy and the grid, we really have to go above code and see the code as a minimum and something that to shoot for more aspirational, but unless that lower threshold is continuously raised. And there are provisions in codes that we're seeing unique that are unique in various places where it kind of forces the design team to look at things like the facade more closely, not just rely on HVAC systems and lighting efficiencies to meet local code, but saying that your building envelope can only be no more than 7 or 15% worse than code, depending on its use. And that makes sense because a building envelope is going to have a longer life cycle than any of the systems of the building. So I think it's really kind of forcing design teams, clients to really look at building performance as not just a nice thing to do for the environment, but something that you have to do. And that's, sometimes unfortunately the only way to move things forward is by requiring it.
So true. Hopefully we can get past that building to the minimum bar. And obviously, Hawaii Energy has a number of programs and incentives to help with that as well. But beyond the low bar, right? And as we talk about getting higher, what do you see the importance around professional recognition to drive building energy performance and literacy within a firm? And I throw that out to anybody on the panel.
I mean, I've been involved the past couple of years with the AIA COAT in New York, and part of, in addition to the energy modeling subcommittee, the awards subcommittee. And what we've seen is a move away from having like a separate awards for sustainable building to merging with the main design awards. And both to recognize projects that are performing well, but also to say that it's not really the best building if it's not performing well, so that the buildings are graded together on multiple criteria, design excellence, as well as how the building performs. And I think giving that recognition and making that an essential criteria can help bake it in, as well as requiring that all projects provide some reporting criteria, such as energy usage and water usage, helps familiarize design teams with those metrics and makes those things more comfortable and more accessible on to understand the subsequent projects, makes them more familiar with it and increases their literacy with them. So I think it's a positive thing to start to view these things together, both performance and design.
And I can add to that a little bit. I think that if the award criteria includes energy and water metrics, it really motivates different design teams to track and analyze their energy use and water use as their design is developed, and test different design options and determine which ones perform best, which ultimately results in a better performing building. So I think it's a good carrot to include those sustainable design criteria in the recognition of projects.
Great, and kind of building upon that and seeing what was done at the Arroyo, obviously having a process, having a design team, involved very early on. Curious, John, from your perspective, and Wendy and Elliot from a broader perspective, what's the difference that you see in an early design phase discussion between energy use in a large firm versus small firms? And, what could we be doing differently or better to again, kind of raise the bar to have these holistic approaches that really maximize efficiency across the board?
Yeah, so our firm's in kind of a unique position. We're a small firm, so we're less than 20 people, but we do large projects like this. Oftentimes we partner with large firms as an executive architect, and a lot of times we do our energy modeling, especially in mechanical engineering, with consultants. So it's really important for us to sort of identify the consultants and project team that will be ideal for meeting the kind of targets that we're trying to reach and that the owner is trying to reach. Because we don't have necessarily the resources to employ specialists or people who do this full time, even if that was their sort of primary interest. So we really try to, in going back to literacy, I think the important thing is that everyone in the office is literate about these things and that understands what each of the metrics are and also how to improve them, so we can give the correct instruction to our consultants. And then when it works with the consultants, it's really great because they often bring a sort of different perspective than we're able to get just from coming from prioritizing design or prioritizing architecture. So it's a good reason to really also get involved in organizations outside your firm, especially as a small firm, because a lot of events and conferences tend to be attended by a very kind of a narrow range of people, and a lot of them come from larger firm backgrounds. So it's really good to do more outreach and really get out there and really learn as much as you can and bring that back into the office. So I was telling a story where I learned the most, what really caused me to increase my literacy and really learn the most, really learn a lot about this stuff was actually a failing energy report. So that was a pretty big motivation right off the bat to really start to understand, because the California compliance software is quite labyrinthine and it's difficult to understand. So it's difficult to tell your consultant, look, we got a failing energy report, how do we improve this? And they say, well, just when you're done redesigning, give it back to us and we'll run the model again. But it's difficult to do that when we don't know the pathway to compliance that we need, how to improve the various numbers to get to where we need to go. So that'll always sort of motivate you to learn this stuff. And then once you do, you can pass it on to other people in your office.
I can add a little bit to that. One piece of guidance that members of the audience might be interested in is the AIA, and I might be butchering the title, but it's something to the effect of Building Performance Simulation Guide. And that talks about the different types of building performance simulation. So we covered energy modeling, but it also talks about thermal comfort modeling and daylight modeling. And you can think about those topics and how you either use in-house resources or work with a consultant to iteratively simulate design options and determine the best ones throughout the design, from conceptual design through CDs. So that's a useful resource.
Yeah, and I think it might reference ASHRAE 209. If it doesn't, that's another resource where it looks at different code cycles, because I think while energy modeling has not been around for so long, I think there's still kind of a traditional approach to it where it's more of a confirmation of the performance of the building. And I think because of some of the new design tools out there, it opens up the possibility for using it as a design tool and not just a confirmation of performance. Because if you wait for it to be a confirmation of performance, you might have locked your design into some suboptimal design decisions that work against performance. And the best thing is to start simulating early and often, even perhaps before you have a building design, to start to identify the parameters like we did in our study that are really going to move the needle the most on performance and help set priorities. And ASHRAE 209 is a pretty good resource as a way of looking at those different code cycles, defining early stage modeling processes like load reduction modeling, then looking at HVAC, starting off at higher, more abstract box models, and then moving slowly towards that ultimate compliance model, where if you've drawn the right conclusions and done the right amount of iteration and design investigation, you'll wind up in a really good spot compared to if you just waited for the end and hoped for the best. So there are a lot more resources out there. It sometimes can be challenging because there is a lot of technical knowledge that's needed, and I've seen worked with all sorts of firms that some do it well, some don't do it as well as far as doing it in-house. Irrespective of size almost, although it is harder for smaller firms to have, a dedicated expert to something like energy or even daylight modeling. But there are always consultants that can help with that process, and it's important to involve that. It's not a handoff, here's the design, go model it, but really more of an integrated design process where the conversations are had earlier on, and you're working back and forth, kicking for back and forth ideas, and then using the modeling to help test and quantify the impacts of those ideas and thoughts.
Right. Thanks, Elliot. Great perspective. I do want to make sure we have time for folks' questions here. So if you haven't already and you have a question, please drop it in the Q&A and not the chat, because I don't want to miss it in there. I have seen a couple of the questions already been answered by our panelists. But one of the first ones I wanted to pose is from the Q&A box is, with all of the combined knowledge between the panelists, is Grasshopper preferred over Revit Insight for energy analysis? And is one software better or preferred for pre-design and another for post-built analysis? So maybe Elliot, you could lead with that.
Yeah, I think to some degree it's going to be a matter of personal preference. My preference is to do a lot of the work in Grasshopper for a couple of reasons. It's very flexible and open source. I'm not limited. There's a number of different other options out there for building performance modeling, and it's sort of more of a black box or more limited in what you could do. And I guess because of the nature of when I adopted this and Grasshopper being so flexible and using plugins to connect it to Energy Plus, which is probably the best, most validated energy simulation engine out there. And while it's not so easy to use natively, Grasshopper gives you that high level control. So you're combining the best of both worlds, this really great flexible engine, and Grasshopper, which gives you a lot of parametric control over it, that's where I like to do my analysis, especially in early design phases, but not limited to it. I've taken building energy models up to like CD level within Grasshopper, and there's continues to be an expanding wealth of tools out there. And I find tools that are based in Revit, either maybe the engines aren't as reliable, or Revit's more of a blocky interface to be able to iterate and do design. However, the lines are always blurring. You can now control Revit from Grasshopper with Rhino inside, and with Dynamo you could do more parametrics. So I think the important thing is looking at the software and how it allows you to break down barriers, not just do energy analysis or data analysis, but what environment is going to allow you to combine them both to see so you're not optimizing one at the expense of the other. So right now my answer is, I like Grasshopper because it's so open source. I could connect these different things, but that might change over time as as all the tools advance and more options become available. To me, the most important thing is the open source nature, because I like to tinker and I like to not be limited by the software.
Great. Thanks, Elliot.
Sure.
We have a really good question here from Michael. The analysis mentions minimizing the fresh air intake and use of split mounted AC, but post-pandemic, it appears there's a movement towards more fresh air intake. So will your analysis track proposed changes from ASHRAE and other code bodies to monitor effects on energy reduction model?
So I can weigh in a little bit, and I can also share the screen if it's helpful to see our comparison of fresh air intake rates. Hold on one moment. So we did test just providing code minimum ventilation rates. So you can see that here in the middle, pointing to the wrong screen, here with the low ventilation rate. So that's just the minimum ASHRAE 62 ventilation rate. And then 130% of that ventilation rate is the high scenario. So you can see the increase on the upper end of the EUIs and the lower end of the EUIs. I don't think that exactly answers the question having to do with future codes, but it does at least give you a glimpse of what happens when you increase the ventilation rate by 30%. So we have that captured in this analysis, and that's also in the article in Technology, Architecture, Design.
Yeah, and it's definitely a challenge because, it's not just energy, but health and wellness, not just when there's a pandemic happening, but under normal circumstances. Air quality in spaces keeps people more alert, healthy. John had mentioned before the MERV 13 filters that are in the Arroyo that has a pressure loss in the ducts, which can increase energy analysis. So that, that is one area where there's sometimes a trade-off between ventilation and energy use. But the hope is, especially in climates where like Honolulu, like Los Angeles, where there's great opportunity for natural ventilation and ways of having thermal comfort with natural ventilation, even if it's assisted by fans, as long as the building creatively, like the Arroyo does, has these big openings to get a lot of ventilation. And I think that could be an effective way of reducing energy use, connecting people with the outdoors, addressing these concerns, but at the same time being low energy, taking advantage of the wonderful climates you have.
Yeah, we're finding that our development partners are starting to become more concerned about air quality in the units. And it's not just due to smog, which was a problem on the Arroyo due to the proximity to the freeway, but also due to wildfires, which have become an acute problem in Southern California over the last 5 years. And it really got us thinking, like, maybe because the code changed, I think in the last code cycle, to kind of go back more towards, you could either do a balanced or unbalanced system. So the balanced system is fresh air that's ducted and filtered and on-demand exhausts, or you could do an unbalanced system, which was basically natural ventilation with an exhaust fan that's continuously running. And it tends, because you're doing, it's like it's less duct work, it's fewer fans. So the unbalanced system is less expensive, but we're finding that the trade-off in energy and cost is, we're finding that because our development partners have a social mission, they're sort of socially minded, they're more interested in sort of these health and wellness issues. So we sort of agree with them that air quality is going to become an acute problem going forward for a number of reasons. And that, so even if the code in the next cycle doesn't shift back more towards ducted fresh air with MERV 8 or MERV 13 filters, we would probably recommend going that strategy anyway, because it does have a big impact on the health of the residents, which is ultimately sort of top priority.
Well, while we're talking about things around the Arroyo specifically, I'm going to ask John, maybe you can rapid fire a few of these answers for us so we can get through things. So I think people are really interested in your project. One of the questions was, with the limit of 63 stalls on site, how many cars from the 64 families are parked off-site?
That's a good question. A lot of the questions I was noticing were a lot of post-occupancy related questions. So if we had someone from the building management team, they probably would have a better idea of exactly how many of the stalls are used and how they're assigned. Generally, there are code exceptions for parking for affordable housing projects. So a lot of times it's not required by code at all. It's generally a negotiation with either the developer who wants to provide these parking stalls as an amenity to their tenants because they probably, they need places to park their cars because they need to drive to work. LA is not known for being, it's a commuter city, unfortunately. So a lot of people do depend on their car for livelihood, or sort of need to drive for livelihood. So we do want to provide as many parking spaces as we can, and that for projects like the Arroyo, which have a lot of family units. There's sort of a balance that we have to hit, because the further down you go for subterranean parking, the higher your building costs. It basically every level exponentially increases your building cost. So we went 2 stories on the Arroyo, 2 levels of parking below grade, because that was sort of the balance of, this is the amount of parking that we can afford for this project, and also the maximum amount of parking stalls we can provide to at least 1 parking stall per unit, so that they can have that amenity. The storm drain kind of provided a challenge. The storm sewer provided a challenge in that respect, in that it's sort of, because it bisected the site, we were limited to doing parking only basically on 1/2 of the site. So that was kind of a difficult obstacle to work around. So we're always trying to find that balance of providing the amenities that the residents need, and also reducing construction costs, reducing sort of complexity of the building design. And now it's become sort of an embodied carbon issue as well. So that tends to be your big embodied carbon driver on affordable housing projects, is the parking. So providing concrete and steel, whereas everything else above is basically wood framing. So we're trying to consider all those things when we, it also depends on where the project's located. Santa Monica parking can be, offsite parking can be a little dicey, but it does have, there are lots of municipal lots. In other spots, street parking is much easier. In other locations, it's very difficult. So it just kind of depends on the location and what type of people are living in the building.
Well, you mentioned that the cars parking in the auto, it has a big part of your reducing the embodied carbon, and obviously the Royal project is a great example of a high performance building from an energy standpoint. But were there any other special measures done for reducing embodied carbon?
Honestly, I think in 2014, 2015, when this project was really getting going, that component of sustainability was not really on the forefront of our thinking. It's only sort of in the last year or two become more of something that we're thinking about. And with affordable housing, there's not a lot of fat to cut out, really. That's just sort of extra, because our finishes tend to be very modest. and that's sort of not just because it's affordable housing, but because it's our office ethos that we kind of prefer more modest materials. So really for housing, the big investment is in the parking, especially if it's subterranean. So it's not that we, have changed our mindset all that much since this project, but I think that we are looking at it when we're looking at how much parking do we provide, since it's discretionary. It is just factoring in, it's one more factor in our equation. And we can start to consider more sort of optimized structural layouts and concrete ingredients, but it really wasn't on the forefront of our thinking back then. The primary thing is just to make the most efficient floor plan possible with the minimum amount of conditioning, and go from there.
Yeah, well, it's definitely coming to the forefront now, isn't it? I do want to transition a little bit to Elliot or Wendy. A really good question came in. To achieve the developer preferred or highest performing EUI, how willing have you found developers to cover those incremental costs required? Because considering that first costs are ultimately a big driver in project planning.
I can start. So having tackled this in my role as an environmental design consultant, one of the ways that we can approach the conversation with a developer or any building client is to use the energy model to estimate the annual energy cost savings. And then we can look at that is from a specific energy efficiency measure. So for example, we talked about the heat pumps. So you might model that, estimate the annual energy savings, and then use a life cycle cost analysis and input the first cost of that measure, the annual energy cost savings, the maintenance cost over 25 years. And then that analysis will give you the net present value by year for that measure. And then the developer can, or building client can decide if that makes sense as an investment for them, and if there are other benefits. So oftentimes the benefits to the occupants outweigh the energy cost savings. So sometimes other measures that have to do with indoor air quality or occupant well-being are even more important than some of those numbers I just mentioned. In addition, one of the other reasons that a developer or a building client might be amenable to picking up energy efficiency measures that go beyond code is there are incentive programs. So Hawaii Energy is one, NYSERDA is one, where the energy efficiency measures that might not otherwise be adopted by the design team because they don't, in simple terms, have a quick payback, would be those energy efficiency measures can be incentivized financially in order to get them into the project and realize those lifetime energy savings and ultimately greenhouse gas emission savings.
Yeah, I agree with everything Wendy said. I think one of the few things to add is that in the consultant role, you're always trying to figure out where the incentive is, whether it, and she mentioned some of the financial incentives, but it also could be using simulation as a way of finding those strategies where you're shifting costs as opposed to adding costs. For example, investing more in the facade and getting to downsize your required mechanical equipment and plant. If you're able to do that, if you're able to use the model as a way to show that you need less capacity, that could be a cost shifting, in addition to the energy savings that are going to be realized later. So it really does require the design team to be proactive and engage in that way to look for those opportunities or find the things that allow you to add by subtraction, such as using less materials, which reduces costs as well as environmental impact. And I think some of the newer technologies and related to performance modeling, parametric modeling could help reveal some of those things and bring it up to the developer as a win-win, and not just, hey, you're adding cost for the sake of reducing energy.
Great. Well, we're coming close to time here, so we've got time for maybe one more question, and maybe I'd like to ask the panelists too if they can check out the Q&A. I think a couple of those could be easily answered in the chat. But as we wrap up here, question around the difference between users and design. So, design can be exceptional. However, how does the user fit into the performance of the building? Isn't there some education on how to allow the building to perform to the optimum?
Absolutely. I mean, you could design, and energy modeling is not entirely deterministic and predictive. It's important to understand that it's for a certain set of assumptions and the way people are going to be operating the building and looking at relative options compared to one another. But it's not going to give you, to the cent, how much this building is going to cost to operate. There does need to, be education of the operators, how to operate the mechanical equipment, especially if there's something complicated in the building, to make sure that it's being done efficiently, and as well, especially in a multifamily building where there's multiple tenants that are individually controlling their space. You could provide them the option of mechanical ventilation or natural ventilation, and they might just choose to use the air conditioning all the time. So those things are really a challenge. But I think the important thing is to be able to provide, a building that can be flexible enough that they do have the option of opening the windows and getting the fresh air and the natural ventilation, and maybe incentivizing that, like in the Arroyo, where you have these beautiful views that people might want to access and go on the balcony for. And otherwise, there have been other projects we've been involved in where there's been an education component and listening to, the building tenants as far as the type of improvements that they would want and be able to live with, to be able to provide those energy and water conserving measures that they're most likely to take advantage of that fit in their lifestyle. So there's definitely a human component to it as well.
Yeah, I think part of the research area where I think our firm is going to try to get into more is doing post-occupancy surveys of not just for residents, but for operations and maintenance staff as well. It's not something we really do often. We occasionally will do sort of year after walkthroughs and just kind of do it very informally. But it would be worthwhile to do sort of a more formal process where we're able to compare and contrast our different projects. Also, just being open with your development team up front and just saying, we want to see the data. So the team at the Arroyo was very forthcoming with any sort of energy and water use data that we requested. It's just you have to ask and you have to be upfront about it. But they're generally very happy to share this stuff because they want to know how they can improve their operations as well from us if we have ideas. So it's really, again, it's about, working as a team. And a lot of times it can help to get residents even involved in the design process sometimes. That way they sort of have, they're invested in these, in their building and, and what goes into it, so.
And John, in our preparation, I think you had mentioned one key element to people reducing their energy use in the Arroyo, and that was that the residences are individually metered, I believe, for their electricity. So that obviously motivates them to cut their own electricity bills. And in addition to that, in our analysis, the energy modeling, we were really aggressive in the high performance cases with the lighting power densities and the equipment power densities and temperature setbacks and even turning off the AC when the occupancy is low. So there's a user education component to that. And I think there's an opportunity to do that, and probably a lot of improvement that could be done there. So at the Environmental Research and Design Lab at UH, we've worked with the Department of Hawaiian Homelands to monitor some of their residents' energy use for a year, identify the most energy consuming components, and then speak with and provide some educational literature, namely a brochure, to the residents through the neighborhood board about ways that they could save energy. So I think there are multiple ways that we as a design community might be able to engage post-occupancy to try to continue driving down energy use in a way that the design was intended to perform.
We definitely see that across the board, you know, whether it's residential to commercial systems where the design's great and without the proper training and education, we lose out on some of that added potential of operating the buildings in the most efficient way. We're up at time. We never have enough time to kind of go through everything, but you know, what a engaging topic and very informative. I want to thank all of you, the panelists, for spending the time this afternoon to share your expertise with all of us here, you know, on this panel. And I also wanted to throw a virtual shout out or a virtual applause from the audience. I don't know how you do this in this virtual world, but I'm sure they also thank you as well for your time. As we close the panel here, we do want to recognize the sponsors for today's event. You can see them here. Thank you very much for your sponsorship and for being able to really bring these important subjects and topics forward as we look at how do we, you know, design better going forward. And lastly, I think we have one additional slide here. No, I guess not. So with that, mahalo to your sponsors. Thanks for a great session. Hope to see you at the next. Aloha.
Aloha, thank you.